Okay, let's solve past question on the course SRE 411. I want you to put down this question. Assume that 104.8 gram of ground wheat was subjected to sieve analysis and the table shows the results. Okay, this is the table for the result of the sieve, the ground wheat that was subjected to sieve analysis. We have the mesh, we have the size of opening, and we have the percentage of material retained. I shorten this so it is percentage of material, okay? Percentage of material retained. Okay, the first question now is that we are told to calculate the value of x. You can see that from this table, the value of x is here. You understand? So we are told to calculate the value of x. And the second question is that find the percent of material that passed through the following mesh. We have mesh 3/8, mesh 8, and mesh 48 and mesh 100. You understand? You know, there are various type of mesh that was used during the experiment. You understand? So the first mesh is 3/8. We have 4, 8, 14, 28, 48, 100. You understand? So we are told to calculate the percentage of materials that pass through mesh 3/8, mesh 8, mesh 48, and mesh 100. Do you understand? Okay, and question 3 now says, assume that 3.85 grams of materials was lost during the analysis. What amount of ground wheat would be used for further analysis? Now, the fourth question, state the range of material in mesh 3/8 and mesh and pan. You understand? Okay, let's start with the first question. Okay, now I want you to pay attention. We have been given the table. We are told to calculate the value of x. That's the first question. In order to calculate the value of x, we all know that x falls in the rows of percent of material. Is that not it? X falls in that row, percent of material. So to calculate the value of x, don't forget that percentage means a number expressed as a fraction of 100. You understand? Therefore, the percent of material must be summed up to 100. You understand? Percentage of the ground meat. The percentage of material retained here. The percentage of the material retained here must be summed up to 100 because when we talk about percent, we are making reference to 100. You understand? All these materials, all the value that you see here has been expressed as the fraction of 100. You understand? That is what percentage means. So in order to get the value of x, we have to add everything in this row. We have to add it together and equate it to what? 100. Do you understand? So to get the value of x, let's start. X, the value of x, which is the first question. We are told to calculate the value of x. That's why I put question mark. To get the value of x, since percentage is expressed as the fraction of 100, so all these materials, the ground width, the percentage of material that pass through each mesh has been expressed 100. They have been expressed as the fraction of 100. So I'm going to sum up these together. So let's start. That is 0.09 plus, what's the next one? 5.82 plus 14.45. 14.454 plus 34.62 plus 18.37 plus x. You understand? X is also part of the percentage of the material retained, though we don't know the value. You understand? So x plus 6.65 plus 3.27 is equals to 100%. You understand? All these are in percentage. Do you understand? All this, there is percentage here. It is because I have already put percent here, so I don't need to put it inside each cells. You understand? So, but they are also expressed. All of them are expressed in what? Percent. Okay. Now let us sum up this. 0.09 plus 5.82 plus 14.54 plus 34.62 plus 18.37 plus x plus 6.65 plus 3.27. If you punch your calculator, you are going to get 83.3 83.36%. So I'm going to have, for this, I'm going to have 83.36% plus x is equals to what? 100%. You know, I cannot add the value of x to this because I don't know the actual value of x in percentage, and that's what I want to determine. So to determine the value of x, I have to what? Collect like terms, you understand? So I'm going to have x is equals to 100% minus 83.36%. Do you understand? So for this, I'm going to have x is equals to 100% minus 83.36%. That is 16.64%. So the value of x here now is what? 16.64%. So instead of x, I'm going to replace that with 16.64%. 16.64%. You understand? It is it's already expressed in percent because I have percentage here. Do you understand? So we have gotten the value of x. We are told to calculate the percent of material that pass through mesh 3/8. Mesh 3/8. That's the second question. Mesh 3/8. Percent of material that pass through the following mesh. Mesh 3/8, mesh 8, and mesh 8, mesh 3/8, mesh 8, and mesh 100. We are told to calculate the percent of material that pass through this mesh. Okay, let's start with the first mesh, which is mesh 3/8. Mesh 3/8. Okay, the percent of material that pass through mesh 3/8. Now, to get the percent of material that pass through mesh 3/8, you know, out of the 100% of the materials that was poured on mesh 3/8, mesh 3/8 is only able to retain 0.09% of the materials. Do you understand? Please pay attention to the explanation. It's very, very important in order to understand this. Okay? Now, out of the 100% of material that was poured on that mesh, that is 3/8, mesh 3/8 was only able to retain 0.09% of the material. Therefore, to calculate the percentage of the material that pass through mesh 3/8, all these percentage pass through mesh 3/8. Do you understand? All these pass through mesh 3/8 because this is the first mesh that we use for the experiment. You understand? We have various mesh. We have, I think, 1, 2, 3, 4, 5, 6, 7. We have 7 mesh. You understand? 7 mesh was used to analyze the ground width of 104.8 grams. You understand? So the first mesh was what? Mesh 3/8. You understand? So we pour 100% of, we pour the total amount of this. This, oh, I want you to know that this is in gram, okay? We have not expressed this in percentage, but here we have already expressed it in what? Percentage. You understand? But it doesn't matter. 100% of the materials was poured on this mesh, you understand? But mesh 3/8 was able to retain 0.09 of, out of the 100%. So in order to calculate the amount of materials that pass through mesh 3/8, we have to sum up the subsequent material that is in other mesh. You understand? Because before we use other mesh, we have already used what? Mesh 3/8. So in order to get the material that pass through mesh 3/8, we are going to add all these together: 5.82, 14.54, 34.62, 18.37, 16.64, 6.65, and 3.27. Do you understand? So that's what I'm going to do now. So the percent of material that pass through mesh 3/8 is equals to percentage. Oh, sorry, what happened to this marker? Now, the percent of material, the percentage of material that pass through mesh 3/8 is equals to, that is 5.82 plus 14.54 plus 34.62 plus 18.37 plus 16.64 plus 6.65. You understand? Plus 3.27. So We are going to add all this together. If you sum all that together, you're going to get that is 99.91%. Please always add your units, okay? Because we are dealing with what? Percentage, you understand? We have already expressed the fraction of the materials in percentage, you understand? So it is very, very important that you add your units, you understand? So that is the percentage of material that pass through mesh 3/8. Now let's proceed to the second mesh, which is mesh 8. Now I want you to pause this video, attempt that of mesh 8, then play the video to confirm your answer, you understand? Now let's deal with mesh 8. Now to get the percent of material that pass through mesh 8, we have to sum up all this together. Every of the materials after mesh 8, you understand? We have to sum it together. You understand? This is mesh 8, don't forget. Mesh 8 is only able to retain the 14.54% of the material that was poured into heat, you understand? So all this pass through mesh 8, you understand? So in order to get the percentage of material that pass through mesh 8, the percent of material that pass through mesh 8 is equals to, don't forget that this is the percentage of material that mesh 8 is able to retain. Mesh 8 is able to retain 14.54% of the material that was poured into it, you understand? So all this, from this place to this place, to the pan, all these materials there pass through mesh 8, do you understand? So the percentage of material that pass through mesh 8 is 34.62 plus 18.37 plus 16.64 plus 6.65 plus 3.27, you understand? So the percent of material that pass through mesh 8 is, if you punch your calculator, you are going to get 79.55%, you understand? So 79.55% pass through mesh 8. Okay, let's calculate the percentage of material that pass through mesh 100. It's very, very simple to get that. I'm very sure you're going to get it. Now I want to ask you, do you get your answer? Do you get 79.55 as your answer? If you get it, kudos to you. Okay, now to get the percent of material that pass through mesh 100, don't forget that out of the materials that was poured on mesh 100, mesh 100 was only able to retain 6.65% of the material. I mean 6.65% of the material. So 3.27, the percentage of material that passed through mesh 100 to the pan, you understand? The percentage of material that passed through this mesh, which is mesh 100 to the pan, is what? 3.27. So that is the percentage of material that passed through mesh 100. Let me just put it here. Percentage of material that passed through mesh 100 is what? 3.27. This is the answers to question number 2, you understand? So for mesh 3/8, that is 99.91%. For mesh 8 is 79.55%, and mesh 100 is what? 3.27. Now let me ask you a question. I want to determine the percentage of material that passed through mesh 4. Though we are not given in the question, we are not given in the past question, but I just want you to try it. Okay, so that is it. Let's proceed to question number 3. Assuming 3.85 grams of the materials, that is wheat. 3.85 grams of the wheat was lost during this analysis. What is the percentage? I mean, what is the amount of materials that will be used to conduct further analysis? It's very, very simple. What are you going to do? If I just think, what are you going to do? Now, this is the total weight of the gram material that we are given. This is the total amount of material, that is the total amount of gram weight that we use to conduct our experiment. Now, we are told that during this experiment, we lost 3.85 grams. 3.85 grams of the wheat was lost. Now, how many of this? What's the amount of material that we are going to use to conduct further analysis? What's the answer? Yeah, we're going to subtract 3.85 from this. You understand? Because that was lost during the, maybe as we are pouring the wheat inside the mesh, inside each mesh, some of the particles, some of the ground materials was dropping on the floor. You understand? We cannot pick it because they have already mixed with the soil. So it might be due to that or various reasons. You understand? We are sure told that 3.85 grams of the materials was lost during the first analysis. So in order to get the amount of ground wheat that we are going to use for further analysis, we are going to subtract the amount that was lost. That is 3.85 grams was lost. So I'm going to question for number 3. That will be 104.8 grams, which is the total amount of ground weight that was subjected to what sieve analysis, minus the one that was lost. The one that was lost is 3.85 grams. 3.85 grams. So if you subtract this, you are going to get you punch your calculator, you are going to get 100.95 grams. So this is the amount of materials that we are going to use to conduct further analysis. Probably if you want to embark on another experiment, which is experiment 2, we are going to use 100.95 grams of the ground weight for further analysis, because this has been lost already. Okay, so let's proceed to question number 4, which is question number 4. That is, state the range of materials in mesh 3/8 and pan. Now I want you to pay attention here. To answer this question number 4, it is important that you understand the classes of reduced materials based on sizes. You know, reduced materials can be classified, and they can be classified into 3 based on sizes. We have the dimension range, we have the sieve range, we have the microscopic range. The dimension range ranges from, and also I want to tell you, if you have not, there is a class that I did on this course that is crash course on this course. You understand? So if you have not watched the lesson, kindly hit the link in the description of this video so that you are going to gain more understanding on this. You understand? Okay, let's proceed. The first class is the dimension range. The dimension range are the classes of material that ranges in size between 0.125 dimension range. Let me just write it. Dimension range. The materials in this class ranges from 0.125 and above. You understand? We also have the sieve range. This is the first class. This is the second class, the sieve range. You understand? The sieve range. The class of materials, the sizes of materials that is in this class ranges from 0.0029 0.125 to 0.0029. You understand? So this is the class of those materials. And the third one is the microscopic range. Microscopic range. The class of materials, the sizes of materials in this class ranges from, they are less than, let me just put it like that, they are less than 0.0029. You understand? So this is the classes of reduced materials that we have based on sizes. You understand? Okay, now let's talk about that question number 4. That question number 4 says we should determine the class of materials in mesh 3/8. Okay, this is mesh 3/8. This is mesh 3/8, Abi. To answer the question, we have to check the size of opening of mesh 3/8, because the size of openings of materials tells us the type of materials, the size of materials that can pass through the mesh. You understand? So the size of opening of materials of mesh 3/8 is what? 0.371, Abi. So since the size of opening of materials on a mesh 3/8 is 0.371, from the classification, the range of materials that we have, where does 0.371 falls? You understand? The 0.371 falls in this range, or did it falls in this range, or did it falls in this range? Please, it is very, very important that you understand this. This is the size of opening of mesh 3/8, and I told you that the size of openings tells us the type of materials, the size of materials that can pass through each mesh. You understand? So we have 0.371 as the size of opening of mesh 3/8. Now, so to know the type of materials that is in that mesh, we have to check the size of opening, and we have 0.371. Now we have to go back to our range, the classes of materials based on sizes. That we have the dimension range, sieve, and microscopic range. Now, where does 0.371 falls to? Is 0.371 greater than, is it greater than 0.125, or did it fall in this range, or is it less than 0.0029? Yeah, it is greater than 0.371, because we say that the materials in the dimension range is what? They ranges from 0.125 and above. That is, they can be 0.126, 0.2, 0.9, 0. You understand? So the classes of materials in mesh 3/8 is what? Dimension range. Do you understand how I arrived at that answer? If you didn't understand, pause this video and watch the explanation that I did. You understand? Please, it's very, very important. These are the basic things that you have to know about sieve analysis. Okay, so let's go to the second question. We are told to state the size of range of materials that pass through, that is inside the pan. Okay, to get the range of material that is inside the pan, don't forget that we are not given the size of opening of the pan. You understand? We are not given the size of opening of the pan, but we can actually determine the range of material that is inside the pan, because it is very, very impossible to have nothing on the pan. You understand? We have 3.27 of the materials in percentage that's inside the pan. So there might something pass through another mesh to enter the pan. So to get the range of materials that is inside the pan, the size of range of materials inside the pan is the sieve range. Now I will tell you how I got that. You know that size of opening of mesh 100 is what? 0.0058. You can see size of opening of mesh 100 is 0.0058, and we know that the size of opening tells us the type of material that can pass through a mesh, abi. So if the size of opening of mesh 100 is 0.0058, that means that the materials that are less than 0.0058 pass through mesh 100. You understand? Maybe they are 0.0057 in size. You understand? Those materials pass through mesh 100 into the pan. You understand? So the size, those materials pass through mesh 100 into the pan. And you can see that 0.0058 is greater than 0.0029. So the size of materials in that range is what? Is sieve range. You understand? Because, and you can also, it ranges between this range. We can also have materials that are microscopic range inside the pan. You understand? So it can either be sieve range or microscopic range, but majorly the answer is what? Sieve range. You understand? So we have come to the end of the question. Please, I want you to watch the lesson I did on this course. You are going to learn various things. I'm telling you the truth. If you want to understand the past questions, just watch the video. You understand? Watch the lesson that I did on the course. You're going to understand every bit of it. You understand? So See you in the next class. Consider subscribing to the channel and also hit the notification bell so that when I drop new video, you are going to get update. Okay, see you in the